Just recently, as piercing sirens once again screamed across the coasts of Japan and Russia's Far East, and the ground trembled uneasily yet again, we have to ask, why is this land, encircled by the Pacific, always so restless? But did you know that besides the familiar tectonic plate collisions, there are other, atypical culprits behind these earth-shattering disasters that you've likely never considered? And more importantly, where is the next high-risk earthquake hotspot? Today, we're diving straight into the geological heart of the matter, a brittle chip hidden beneath Japan and Russia, squeezed by three major powers. It's a broken heart known as the Okhotsk Plate. We'll explore why it's the key driver of the frequent earthquakes in this region. And finally, we'll try to decipher where scientists are tracking the next high-risk hotspot, the root cause, Earth's broken heart and its conventional energy release. To understand the earthquakes in the Japan-Russia region, we first have to visit Earth's broken heart, the Okhotsk Plate. It's not a vast, giant plate, but a relatively small microplate, like a brittle chip sandwiched between the North American, Eurasian, and Pacific plates. This unique geographical position seals its fate, and the fate of the tens of millions of people living above it. It must endure constant, immense pressure from three different directions. The most powerful and direct source of this pressure comes from the Pacific Plate to the east. This is the classic geological process of subduction. During this process, the contact zone between the two plates gets locked tight. However, the Pacific Plate never stops pushing, causing a massive amount of energy to build up, just like a spring being compressed further and further. When the accumulated stress finally exceeds what the rock can handle, that spring violently snaps back. This is a thrust fault earthquake. The seafloor is suddenly thrust upwards by several, or even tens of meters, instantly lifting billions of tons of seawater above it. Under the force of gravity, this water then spreads out, forming a devastating tsunami. The recent powerful earthquakes in Russia's Far East and the resulting tsunami warnings in Japan are a direct consequence of the Pacific Plate releasing its conventional energy beneath the Kuril-Kamchatka Trench. This is a classic, textbook cause of earthquakes and tsunamis, and it remains the primary threat in this region, unmasking the atypical culprits, the unexpected causes of tsunamis. However, if you think all tsunamis are caused by this conventional plate movement, you'd be underestimating the Earth's complexity. Now, let's pull back the curtain on the atypical culprits. First up, the silent killer from the deep sea, underwater landslides. Not all earthquakes can directly trigger a tsunami, but a strong one is more than enough to shake loose fragile underwater mountains or sediment layers, causing submarine landslides of staggering scale. These landslides can displace several cubic kilometers of material, unleashing enough energy to create monstrous waves. What's even scarier is that sometimes, you don't even need an earthquake. When enough sediment builds up, it can collapse under its own weight. The 1998 Papua New Guinea tsunami is a tragic example, where a 7.0 magnitude earthquake triggered an underwater landslide that generated a tsunami up to 15 meters high, causing absolute devastation. Second, the furious roar from within the earth, volcanic eruptions. When a volcano's fury is unleashed beneath the sea or on an island, it can also be a tsunami trigger. For example, a violent eruption can cause the volcano's structure to collapse, forming a massive caldera. The surrounding seawater rushes in to fill the void and then rebounds, creating a tsunami. Alternatively, scorching hot pyroclastic flows can race into the ocean at incredible speeds, displacing huge amounts of water. In the most extreme cases, the entire flank of a volcanic island can collapse into the sea. The 2022 Tonga eruption was a vivid lesson for scientists worldwide on volcanic tsunamis. And if volcanic eruptions are the Earth's fiery wrath, then on the other side of the world, its icy side can create monstrous waves too. Even in the distant polar regions, the collapse of giant glaciers can trigger deadly fjord tsunamis in localized areas. These atypical factors are a stark reminder that the ocean's threats are far more diverse and unpredictable than we often imagine. Tracking the pulse, how scientists pinpoint the next hotspot. Faced with such a complex planet, we have to be honest about one thing: with our current technology, it's still impossible to precisely predict the exact time, location, and magnitude of an earthquake. But impossible to predict doesn't mean impossible to prepare. Scientists, like top detectives, are tracking the Earth's pulse to identify the areas with the highest risk. First, they look for seismic gaps on an active fault line. If a particular segment has gone a long time without a major earthquake while the surrounding areas have been active, it's like a fully drawn bow. This segment is likely accumulating energy for the next big one. Second, They use a global network of GPS and satellite radar, (SAR). These high-precision instruments can detect millimeter-level changes in the Earth's crust. When the data shows that an area is being continuously warped and compressed, it means the stress underground is rising dramatically. Even more crucial is monitoring a strange phenomenon known as a slow slip event. This is an unfelt, gradual sliding of a fault. It doesn't produce any shaking itself, but acts like a silent mover, transferring stress from one area to another that is locked. This significantly increases the risk of a major earthquake in the locked zone. Monitoring slow slip events has become a key scientific tool for identifying potential future earthquake hotspots. And for tsunamis, we have deep ocean warning systems like DART. These buoys, deployed in the deep sea, can monitor changes in water pressure in real time. If they detect a tsunami wave passing by, they can send out a warning to coastal areas within minutes, buying precious time for evacuation. The final prediction: the next focal point from northeast Tokyo to the Kuril Islands? So, after combining all this data and these models, where is the next focal point that has scientists most concerned? Based on the latest scientific research and analysis of historical earthquake patterns on the Okhotsk Plate, one region is under intense scrutiny, a stretch extending from the waters northeast of Tokyo, along the Japan Trench, all the way to specific fault segments in the Kuril Islands. Why here? The reasons are complex. It could be because this vast area contains several seismic gaps that have been accumulating energy for a long time. Or perhaps the crustal deformation data shows that stress has built up to an astonishing level. Or maybe it's the frequent slow slip events that are steadily pushing the pressure toward a critical point. We must emphasize that this is a high-risk probability map based on scientific models and data, not an absolute, destined prophecy. But that's precisely where its importance lies. Even if we can't predict earthquakes exactly, understanding these high-risk areas helps us prepare more effectively from urban planning and building codes to public education. Every pulse of the Earth is filled with the unknown, but with science and knowledge, we are striving to unlock its secrets. To understand why Japan and Russia experience so many earthquakes is to understand the land we live on, and the connection of both awe and intimacy we share with our planet. So, what do you think? Will humanity ever be able to fully predict earthquakes? And hey, if this prediction ever comes true, remember to come back to this video and let us know. Drop your thoughts in the comments below.